Hello everyone, my name is Hua Qi. I'm a graduate student at Kyushu University. Today I would like to introduce our paper, Few-Shot Guided Mix for DNN Repairing. Our task is effectively repairing DNN software after observing failure cases on its operational environment by retraining or fine-tuning the DNN model with failure cases. But there are two challenges. The failure cases are quite scarce, and the DNNs can only deal with the cases in certain distribution, which cannot cover all real-world data. So we propose a novel DNN repair method to solve the aforementioned challenges, which is FSG mix. First of all, we formulate the failure data-driven DNN repairing as a data augmentation problem. Basically, data augmentation follows these four steps. First, sampling example cases and randomly choose their operations. Then augmented the sampled cases and mix them together with their weights. The weights are sampled by a fixed and predefined distribution. Obviously, they cannot be perfectly adapted to a specific dataset containing failure examples collected from the real-world environment. So, we need to develop a new operation sampling method by considering the failure examples and generate the suitable weights. As a result, we propose FSG mix to solve the problem. FSG mix generates the operation weights according to collected failure examples and can be embedded into data augmentation method introduced in former slide. This is the algorithm of FSG mix. For the GS example in the collected failure dataset, we first learn its operation weights to enable the augmented version to be correctly classified by the DNN. To this end, we calculate each failure example's corresponding weight by solving this equation. As a result, we collect weight vectors and construct a set W. Then we use the W to fit an n-dimension Gaussian mixture model via the expectation maximizing algorithm. After that, for the image in training dataset and failure examples, we randomly choose two images and sample weight vectors using fixed Gaussian mixture model. After that, we generate their augmented images. Finally, we calculate the loss function and update the parameters of DNN. This is an iterative and incremental process. In the preliminary evaluation, we validate the effectiveness of our method via the classification task. We test our method on a state-of-the-art DNN architecture, wild residual net. We select 3 typical augments and their combinations as augmentation operations, and augmix is our baseline. Compared with the state-of-the-art data augmentation method, our method with Gaussian mixture model achieves highest accuracy. An accuracy difference between different training sets is much smaller than that of the other methods. Shows its advantage in generalizing to specific failure cases and high generalization with a small dataset. In the experiment of evaluating toleration to different kinds of failure examples, we use randomly generated weight vectors to degrade test images, which represents a kind of failure examples that cause DNN misclassification. Then we use the repaired models used in former experiment to classify the 3 generated sets. The result shows, although the accuracy of all our methods becomes lower, our method still achieves the highest accuracy. The result of these 2 experiments demonstrate using fixed weights for combining augmented examples get low accuracy, but jointly modeling all weights with the Gaussian mixture model could achieve much better accuracy. In conclusion, we designed a novel augmentation-based repair method, FSG mix, making the first attempt to solve the scarcity and generalization problem surrounding the limited amount of failure cases. It's also a feasible solution towards the data-driven DNN repairing. We will explore more augmentation on our method and apply it to other domains in the future. Thanks for listening.